but there's one thing I have to do here to make this feel more like an NDC. Alexa, turn the media room to purple. Now it's an NDC conference. Okay, so thanks for coming to the talk. This is Fluxing Up Your .NET Apps, and I'm Alex Dunn. Let's see if we can get this going. So you'll find me online, not as Alex Dunn. I mean, in some capacity I will be, but you'll find me mostly as Suave Pirate. The reason for that is basically, or I should say the story behind that is basically that my name is so ordinary, especially in the States. I work a lot in the Microsoft stack and .NET, and there are multiple Alex Dunns that work at Microsoft as developers. So I use the name generator I wrote as a kid. We landed on Suave Pirate, and that's where I am all over the internet. So on Twitter, on GitHub, even my LinkedIn URL, and most recently on Twitch, where I stream every Wednesday and Sunday, building all sorts of cool stuff. We do a lot with conversational AI and virtual assistants, mobile, and usually a whole bunch of .NET. I'm also a Microsoft MVP in .NET Tech and AI, and I'm also a Pluralsight author, mostly talking about Android development and application development. So definitely check all that stuff out. So we're talking about Flux, and we'll get into what all of that means and what it is and design patterns as a whole and where we stand. But like I said, this is talking about design patterns and sort of high-level architect stuff. So it'll help to know, but there's sort of like two things. Either have experience doing client apps in .NET. That could be Xamarin.Forms, that could be UWP, that could be Windows Phone. If you're like me and did that back in the day, I miss my Windows Phone more than anything. Familiarity with XAML is going to be super helpful, although even if you don't have that, we can always answer questions on it. And then familiarity with MVVM and bindings, because we are going to be doing a lot of comparison, especially because, well, I should say, until recently, the .NET client-side app development cycle between WPF, UWP, and Xamarin.Forms, it's all about XAML and MVVM and bindings and stuff like that. And we're going to try to kind of break that mold a little bit in this talk. Right, that's the left half. If you're familiar with that, you're great. You're gonna do awesome here in this talk. You should be able to pick things up I'm talking about. If not, ask questions. If you don't have that stuff, and instead you have familiarity with building client apps in React, that could be React Native, that could be React for web, or if you're already familiar with Flux or Redux or something like that, or at least object-oriented JavaScript, you're gonna do great because we're talking about this stuff in .NET, but they're patterns that really originated from that side of the world of development, from React, from the Facebook team and Redux and Flux, and we'll get into all that nonsense. I'm going to be putting these slides up, but just for some reference here, all of the stuff we're going to be looking at in demos, it's all on GitHub online. There's Xamarin Flux, and then we'll get into a bonus demo a little later as well, which I didn't want to spoil here. I also built an SDK for this that can help a little bit, just called the Flux Toolkit for .NET. And then there's also some docs here, and then the original Xamarin University guest lecture where I sort of brought this stuff into the fold for the first time. But all that aside, introductions aside, nice to see you all. But let's get into talking about what we sort of currently see in the application design pattern side of things, for the most part, and especially in the mobile world, regardless of .NET or not. So as an example, we have model view controller, that's MVC. And so the structure of that is kind of like this, right? We have our model that can be everything on the data side and back. We have our controller, which is then responsible for handling the communication between our views. So our controller can receive data from requests from a view, and then it can send stuff back down to manipulate that view. That could be like, ASP.NET MVC. That could be iOS, which is sort of pushes you into an MVC build with view controllers. But you can also implement it wherever, right? It's just a design pattern here where your controller is responsible for basically relaying information to your view with both sending and receiving data from your model. In the Android world, we have MVP, which is Model View Presenter. You'll notice that, I'll go back and forth. Between these two slides, I literally changed one box because at a high level, it's the same thing. Your model sits behind the scenes, that's your data. Your presenter is then in charge of choosing what is sent up and down from your view. We also have Model View View Model, which is extremely common in the .NET space. WPF, UWP, Xamarin.Forms, even in native stuff, and even across other platforms as well. MVVM is huge. And basically, this whole talk started because I hate MVVM, and I'm so sick of it. And I hate the verbosity and the debugging of issues with it and stuff. And all the problems I've had over the many years of doing MVVM based development, and that's sort of where we landed here. But either way, my opinions aside, we have the same general structure. We have our model, we have our view model, which is then in charge of doing that sending and receiving of data to the view. The only difference between these three, right, between MVC, MVP, and MVVM is like the nuance of how they send and receive data. Like MVVM, it's usually done over binding, so you're not doing like explicit sending or receiving. Instead, you're binding properties two-way and you're binding commands for actions and things like that. But either way, in general, it looks like this. So let's talk about problems with these design patterns. Let's talk about problems with MVVM especially. So the first thing, whoops, sorry about that. The first thing is this bidirectional data flow. So looking at these sort of core components, the model stuff is fine. We don't necessarily care about that because our data's got to live somewhere and it's got to be able to communicate down to our view in one way or another. But let's talk about this bidirectional communication between our view model and our view. Between all of those patterns, we saw that we had that send and receive data setup and our view. The issues come when we have the bidirectional communication that's hard to sort of like separate. That relationship between our view model and our view is actually pretty tightly coupled, even if it's really not meant to be, and we try to tell ourselves it isn't. We have that tight coupling of our view to our view model. Now, beyond the bidirectional issues, we also have what I call cross-base. It's really like in this scenario where I have view model all over the place, it's about cross-view model. So in an app, like an actual production app or anything else, even just one with multiple pages, this is generally what your architecture is going to look like. You've got multiple view models that are tied to a view, and they send and receive data. But there's no rules that really dictate how these should be communicating to each other. So a lot of times what we see is a diagram that sort of looks like this. And view models can just send stuff to each other. And this is sort of like an early stage of people learning MVVM. I see this sort of implementation a lot with folks that aren't familiar with abstractions and service layers and things like that. So we go from this sort of messy mesh of view models just sending stuff to each other, and it's hard to keep rules around that, and it's hard to track down bugs when something goes wrong. So the sort of natural next rule is to add a service layer, an abstraction over it. But this rule isn't strict, and we can get a little better. We can use dependency injection. We can inject our service layer into our view models. So now we can handle sending stuff up and down there. That's sort of helping mostly separate the model from the view model, not so much that cross-model communication, but it certainly can. Some examples of that would be like like navigation service pattern, right? When we want to navigate to another page, we don't just say from our view model, go open this page. Although I do see that all the time, but you're not supposed to do that. We see like you inject a navigation service and you say navigation service navigate to this page, and that will handle setting up the view and the view model and everything else. There's another layer you can take to this. You can abstract your data access layer. So now you've got a nice separation of like data layer, business logic layer, view state layer, and view, and that's great. But there's still no rules around it, and it still sort of leads to making it difficult to run it, especially in a team environment. Building and managing apps at scale that can easily sort of start to fall apart, because that relationship between your service layer and view model layer, if you're not setting really good rules around it, someone can just implement something wrong, and then we run into issues with tracking it down. Now, that's all just from the view model up. We also have difficulty testing and debugging the actual bindings. You know, the bindings are meant to abstract your view model and your views relationship. That's the whole goal of it. But that goal comes with consequences, or that feature comes with consequences. And essentially, it's that if you run into an issue with a binding, it's pain to figure out. I'm sure some of you have had it in the past, and other times if you set it up right, you don't necessarily have to worry about it. But usually that separation, and especially doing things over like string property relationships and stuff, makes it really difficult. So for example, I could just have like a typo in my binding of a property and like not be aware of it. Like even if it's like case sensitive and I just like didn't capitalize the name of the property I'm binding to, in some scenarios that will be caught by build issues. But even in that scenario, I might not just realize right away like, oh, I typed this with a lowercase instead of Pascal casing it. And that is just annoying. It feels like a problem that us as developers can get around it and not have to worry about. And then lastly, there's difficulty in testing and debugging that service layer relationship to the view model. Now, if you're doing dependency injection properly, that doesn't necessarily mean it's really difficult. You do have the ability to unit test very easily now. You can mock your service layer and test certain scenarios. But when it comes to that real world implementation, where there's sort of this like mystery of what's happening behind the scenes between these two view models communicating, that's where we run into issues in production with trying to understand what's happening, right? So let's talk about where Flux comes in and how it can actually help with some of these scenarios. So I'll introduce the concept in general, and then we'll talk about how it works in those specific cases to help fix it. So at a high level, here's sort of my go-to bullet points when talking about Flux. It's a client-side application and application architecture and design pattern, meaning that it's just another sort of tool in your tool belt. There are libraries that are there to help with this. You know, like I said, I built one for .NET, mostly for like my Xamarin apps. But in general, it's just a concept. There's no like hard implementation of it that you need to use every time. I'm not here to promote a library or something like that. It's just a design pattern. It was originally set up by Facebook and for helping build like really large scale and robust data-driven UIs. So this is where we start to get into like massive scale of an app. And like when I say scale, I mean like the actual like features within the UI and the app and the data within it itself, right? Like Facebook builds these insanely functional applications from Facebook itself to Messenger to like the other 30 they have. So basically their original implementations of state management and React when they were getting that started just wasn't enough. So they introduced this design pattern and it really helps a lot with that. The focus is on the flow of data and separation of concerns. There are other patterns out here that are very much like this and tools that try to help with these same things. And same with that next bullet point there, the unidirectional data flows. And that could be like reactive or reactive. I keep trying to say like the JS one, but reactive UI extensions would help with this and the whole reactive pattern in general. It's the same goal of like having that single flow of data and just listening to events propagate through, but this just sort of implements some more rules on it as well. So if you've come from the React world, there's some sort of nomenclature I want to translate over when we talk about it in these samples that we're going to do with C# and Xamarin later. So for example, a component's render function in React is the same as having your actual page, right? That's your raw UI. The component state, we're still going to actually use a view model and data binding to make the most use out of what we have there. The props are properties, that's no different. And then the component lifecycle of like component will mount or did mount, component will unmount, stuff like that in React. That's just the same as the page lifecycles, like on navigated to, on navigated away, or can never remember the ones for the other platforms. But either way, there's a pretty good pairing here with how we're talking about this translation. So let's talk about the structure, like what Flux really is. And it's really made of 4 main components, and that's all you have to think about. There are actions, and an action basically does some business logic and then communicates to the dispatcher, right? Our little guy over here on the right side. The dispatcher then is responsible for taking information from the action. So the action does whatever it needs to and says, hey, dispatcher, dispatch this thing. And the dispatcher is going to say, all right, let me go send all of that information to whatever stores you have. These stores take the information from the dispatcher, regardless of where it came from, does something to update the state of the data that's within it, and then it's going to propagate or emit those changes down to the views that are subscribed to it. So there's sort of like a 3-level subscription here. An action happens. We don't care where that came from. We send stuff to the dispatcher explicitly. The action literally calls the dispatcher. Stores subscribe to dispatchers and views subscribe to stores, meaning that a store can be thought of as sort of like an abstracted view model across all your stuff that's really just focused on data structure and not view data structure. So action to dispatcher, dispatcher to store, store to view. And it's just that single sort of circle there. Like we said, focused on a unidirectional data flow, and everything sort of follows suit there. So what that means is your app architecture, instead of going from like that cascaded set of like views and view models with the bi-directional thing, it's just a whole bunch of these loops. So you have one setup where you have an action to dispatcher to store to view, and then you have another one. And really your whole app is just a collection of these loops. And it's a really interesting way to think about your structure of your data in the app, the structure of your state, and the structure of your views. It's really just a collection of these loops, which means they're really easy to follow, because if you run into an issue with just one of those, you just go into where that whole sort of loop happens and you're good to go. Now, let's talk about adjusting it for the sort of MVVM in the .NET world, because in its current state, we have XAML for our primary way of building views, and we have the benefit of data bindings using that. Benefit could be, debated, but I like to think it's at least useful. So the only difference here is that instead of just having the store listen to the, or have the view listen to the store, we instead have a view model listen to it, and our view model just communicates bidirectionally to our view. But the rest of it is still the same. Instead of having the view actually execute an action, we just leave that to the view model. So really, we're sort of combining these two design patterns because they fit pretty well together. We let the view and view model be its state and view. We don't have to really worry about like two-way bindings. We can do like one-way bindings. But then we get all the benefit of the state management and the sort of high-level abstraction of our data and our state within our app. And we let Flux take care of that. We let our stores keep that as our source of truth. We let our actions be the ones that dictate when something's changing. And we let our dispatcher sort of handle the communication. Is that all making sense so far before we dig into it? Like I said, if you guys have questions, throw them in the chat. So like I promised, we're going to talk about those problems that we had with the other architectures or design patterns like MVVM and how Flux can make those a bit easier. So the first thing we get, and we've talked about this now a few times, is that unidirection of data flow, meaning that we don't have to worry about the mysterious issues of two-way bindings. We can enforce a single direction. If the view model needs to update something on the view, that view's property should not be able to update the same property on the view model. It should be one way, either from the view to the view model, or from the view model to the view, or the view to the view model. So for example, even if we're binding to like a label, right? It's just a label or a text block. If you're in the WPF UWP world, if you have a text block, your binding should only come one way from the view model. If you're doing a text input, like a text box or an entry, then it should only go from the view to the view model. If you make a change in your view model, you want to avoid making that as a two-way binding. It should always be one way. And that way we can enforce that full control from MVVM all the way through the Flux process and follow that track of the data in one direction. We also get trickle-down control, and we're going to go into some more diagrams in case you didn't get enough of the ones so far. And the trickle-down control is one of the most useful parts of it because it also makes it easy to follow what's happening, but also hit that really large scale of data and views. We have a single source of truth. If we have something wrong with our state, we don't have to go find what view model like changed and what happened. We just go to the store. Each store owns its DTOs, its data models. We know if something goes wrong, we go there, we fix what's happening with our data, and we move on. And it plays well with other UI patterns. Like we just said, it works really well with MVVM in this scenario, but it also, I think more importantly, plays well with other sort of system or architecture design patterns such as dependency injection, mocking, and everything else that makes that testability really easy to control. That's one of the benefits of having that separation of concerns that we get from like MVVM and MVC, and like we talked about before, dependency injecting the service layer and data layer. We can still get all those benefits and it works really well. And we'll take a look at that in the demos as well. So, but let's talk about that trickle down control. So like we talked about the single flow, right? An action talks to the dispatcher. Dispatcher sends stuff to the stores that are listening to it, and the stores update the views or the view models via a subscription sort of model. Now, that doesn't have to be a single sort of loop there. That doesn't mean that one view can only call one action, which can only hit to an event that only one store listens to. Your views can technically affect each other by having multiple subscriptions happen. So like in this case, we have an action that happens. We don't care where it came from. Action 1, send something through the dispatcher, right? Let's just say it's like an item added event that we just tell the dispatcher this is happening. We can have two stores listen to the same event. So now I've got store 1 and store 2 listening to this event. And store 1 is being subscribed to by 2 different views. So this one action actually could affect 3 completely different views. Now in the world of .NET client apps, that could be full pages and we're even updating stuff behind the scene, or that could be like subcomponents and stuff like that. So let's get into some more complex scenarios. One view can fire two different actions. So we've got action one, action two. View one says both of these actions are going to happen. We also have two different stores. So action one is being dispatched. The dispatcher takes it, and store one and two are both listening to it, but store two is only listening to action two, and store one is not. Then view one and view two are listening to different relationships between store one and two. So once again, like one underlying view just affected a whole bunch of stuff, but it's all just trickled down. It all runs through the dispatcher to our source of truth, which is our stores, and then we're able to basically go take a look at our views and see what's going on. Now, here's an important note that I always want to emphasize. We always talk about the sort of pure Flux flow of a view sends an action to the dispatcher, to the store, back to the view. But views are not the only thing that can execute actions. So, for example, we've got this scenario here, back to the sort of .NET example, where we've got our view and view model totally separate, MVVM style with single way bindings. View models can send stuff to actions. That's great. That's our perfect, beautiful, super easy flow that we've got set up. But I could have a background event also fire an action. It could be the same action. So some examples of that, we have a WebSocket connection. And this is where I really dug into the sort of Flux scenario for the first time, building a real-time chat app. So if I am typing a message in the app, and I hit send, that's an action from a view, and it sends it to the dispatcher. We say, hey, we're sending a message. The action maybe sends that to a server that does something with it. The dispatcher then goes, hey, we have a new message to add. The store goes, hey, I got your message you just sent. Let me add that to local state. So now your message is going to be propagated to your view model, and it's going to show up in your list. But when someone else sends that information or sends a message from their app, we receive that over something like a WebSocket event. So now I sent my message, and that stays within the loop. If I receive a message from you, your message can just fire an action the same way that me sending it does. And that means I just get the event. I say from my code, let's say we're using something like SignalR, and we're subscribing to an event on like message received. We say, hey, on message received, just go fire this action. And that's all we have to care about. We don't have to say, hey, on message received, go do this thing and put it in state, and then like let's make sure that actually updates the view. We just say, we got that WebSocket event, fire the action. And the rest of it's handled by our setup the same way that it is if the event came from the view. Another example of that is like a location update event. If you're building a map app, your update could come from the user changing the position of the map, or it could come from their actual location changing on their device, which is not directly from a view. Similarly, from an accelerometer event. So if I'm doing something and moving my phone in this scenario, those events that are firing in the background can update the state and update the view simply by just saying, hey, this action happened, right? On the other side of things, views or view models in this case are not the only things that can subscribe to stores, right? Again, we've talked about the perfect flow, view, action, dispatcher, store. But in this scenario, the view model isn't the only thing that can listen to a change of state. We might have a background task that we want to execute whenever we actually fires an update from our store. So we could have a view execute a command on our view model, which then fires an action globally. It does its business logic. The dispatcher takes that and says, hey, store, this event just happened. Here's the data. Go update your state. But a great example of this would be like doing a data sync remotely. So when my local state updates, I could also go update my state across my APIs or something like that. And I think that use case is really, really interesting because the sort of offline data syncing has been a challenge in the mobile world that no one has done really well in a long time. And this is the first solution that I've had that I was actually really happy with the way that it was set up, because it makes it super easy to say like my app state can also just be over here in some remote data sync, but it can also be just updating like a local database. So if I have my local state in the store in memory, I can also go update that on an actual like SQLite or some sort of document store just on my device, which it's an amazing setup to have because I now don't have to care about the rest of that flow. But I know if something goes wrong with setting local data, I go to my source of truth, which is my state in the store. Cool. So assuming that all makes sense, I hope you guys are done with block diagrams because I sure am. So let's talk about an actual demo. So what I'm going to walk you through is a Xamarin.Forms app that uses Flux and MVVM, like we talked about, and also inversion of control and dependency injection. All of this stuff is on GitHub. You can go grab it from my GitHub. It's at /swabpirate/xamarin.flux if you want to follow along. But I'll talk you through the project structure before we really dig into the code itself and start to run this thing. So we have a basic sort of XAML .NET standard Xamarin.Forms template. It's the usual stuff. We have our .NET Standard library, we have an Android project, and we have an iOS project. Everything that we're doing Flux side is all in the shared code, right? So we're still getting the benefits of everything else we do, where we don't really have to worry about like Android specific stuff or iOS specific stuff. But let's talk about like the Flux specific components in here. So we have our actions in a folder. We have an I action and a to-do action. We have an action type for to-do action types. It's basically just like identifiers for what the action is. We have our model, which is a to-do app. We have our startup stuff, which is all like inversion of control config for dependency injection and all that good stuff. And then we have our store. In this case, we have the event args for it. We have a base class to handle some of the binding stuff. And we have our to-do store. And then we have our view models. We have a view model locator for pulling it out for dependency injection, so we can just actually bind directly to an injected version of the view model. We have our to-do list page view model, and then below that we have our views. So what we're actually creating here is a super basic app, your most traditional, basically hello world in the mobile world of creating a to-do app. So we can do things like view our items. We can create items by giving it a name. We can then say that it's toggled to complete or not. We can delete them. We can edit them. We can populate it with a whole bunch of stuff. We can delete all of the ones that are completed, and we can toggle all of them to true or false, right? So like in theory, we should be able to say like, hey, all of these are complete now, also wipe them. So let's go take a look at the actual source code. So what I wanted to do, see if this is the right one. I've got two versions of it up right now. This is not the one. I don't want to spoil it. So we've got this empty solution here. And what I want to show is that instead of showing you what it looks like in the end, I want to show you what it looks like without all of the Flux stuff. So let me start by going into views, and let's go take a look at our to-do list view. So everything we just saw, right now, this is no Flux. This is just a pretty straight up MVVM scenario. Let me know if that's big enough to view too. I can always change it. But essentially what we have here is a single page. We've got a list view, and we've got our binding context set up, which is saying that we're going to go to our static resource of locator and get that to-do list page. I'll show you where that lives in a second. We then have our toolbar items for like populating, creating a new one, clearing the ones that are completed, and toggling all of them as either completed or not completed. Our list view is then binding to the items property of our to-do list page, and then our data template is just a text cell where we're just saying get the text of the to-do item, and if it's complete, we're using a string format to say it is complete, true or false. We then also added context actions to these to be able to delete them, toggle them, or edit them, and that basically exists as a like on Android it'll be like a tap and hold thing, and it changes the toolbar out, and on iOS that exists as the like swipeable things, although you can do that on both now. I'm also just getting my phone set up so that way I can actually run it for you and show you on Visor. I'm running on Windows right now, so it's going to be hard for me to show you the iOS app. I don't have my Mac running right next to me, but I'll be able to show you Android. Let me clear all these. So anyway, that's our view. Let's go take a look at our view model that's behind it. So we have a to-do list page view model. Looks like it just didn't grab my stuff. Let me see if I can just build it, just so we can get rid of some of these squiggles. Oh, cool. Yeah, I know. I don't have it set up on this machine, Cliff, for using hot restart in Xamarin. That, and I also don't have my iPhone next to me to be able to run, so I would need to run it on the simulator. Okay, either way, I mean, it's going to look exactly the same. It's like the most basic app in the world. One that arguably should not be over-architected with Flux. Let me try to figure out why all of a sudden I got all these squiggles when I ran this morning. Let me restore NuGet packages here. I mean, I can talk through it with the squiggles either way. Rebuild all failed. That's lovely. Okay. Either way, well, let's just talk through it and ignore the squiggles. So we have a private observable collection. We have commands for the create toggle, toggle all, delete. And I wanted to make this as like unopinionated as possible in terms of like frameworks and libraries. There are much simpler ways to do this stuff now. Like you could just use Fody to handle the way that I'm doing, like the iNotify property change for the MVVM. But like I said, I didn't want to introduce libraries that people might not understand in this sample. So we have the create command, and basically we're just using the relay command from MVVM Lite. And then we're using Alan Ritchie's user dialogues, which is like the first library I always add in every Xamarin app I ever build, to be able to say from here, we just want to prompt the user with some actions, and then we're going to create our to-do from here. And then basically we register all these commands, and they all actually do the business logic within them. So you'll see, like, in this case, we get the items and we take the first one and we update the text. And if we delete it, then we just remove it from the items. And this items is our observable collection, which means when we bind to it, any changes made to our observable collection behind the scenes will also propagate because we're two-way binding everything. So that's all it is. We just have that list, and we have all of these commands that are actually changing things on it. Now let me walk you through the setup. So from the app XAML, we register a viewModel locator, which is going to be registered as a static resource called locator, which is why in our page we can set the binding to locator, and then we're going to grab the specific properties off of it. So if we go look at that locator, we're basically saying, like, go get an instance of our to-do list page view model. And we'll get the other one to build because I have it running right now. But essentially, we're just saying, go get me an instance of this, which will handle all of the dependency tree crawling and creating and stuff like that. And then our IOC config basically says that we can register actions and stores, which we'll get into, and then we can register our view model. So our view model doesn't need anything injected into it because everything is just running from here. Everything is just local state within a view model. Now that means if we wanted to do more with this, such as like creating a new page for editing the details instead of doing it all on one, we'd have to be able to start passing those parameters around, handle understanding the state in an abstraction. So like if I edit the name on a different page, how do I make sure that that name is edited when I get back to this view model? And that's the sort of challenge that we can solve with Flux. But let's get out of this one because I'm sick of all the red squiggles. And I was hoping to be able to actually type some of this up, but it seems like those builds are going to be annoying. So we'll just walk through the completed one. So like I said, we have all these things now added. The original one was just the view model and the view model locator in this startup. So we added a few more things here. We have our actions, action types, and stores. Those are the biggest changes. And then we also have some new things set up in the IOC config. So let's first go take a look at our to-do list page view model. So the biggest differences here are that we still have all these commands, but we also now have private read-only to-do store and to-do actions. Now, the reason for that is, again, like our view model is able to execute actions. So we need a reference to the class that controls these specific actions because we can sort of scope them into our domain. We then also need a reference to the store. That way we can subscribe to changes to it and be able to update the things that are happening behind the scenes. And then we also have our items, and we have the same commands. And the biggest difference within each one of these commands, such as the create command, is that we're not actually changing that items property anymore. We're not saying, okay, we're going to create it, so tell the items to add a new one. Instead, we just say, hey, to-do actions, we're adding a new to-do, and here's the text that the user entered. Same thing for edit. We just say, we do the prompt in the UI, because this is all UI-based stuff, and we say, hey, actions that we edited this one, here's the ID and here's the text. Toggling, we're just saying, hey, toggle this one by its ID. Toggle all just sends an action to do all of them. You'll basically see like all of these commands are now just abstracted into our actions. This could be done even more abstracted, where basically we don't even have the commands and the commands actually exist within the actions, but that could be a little bit overkill. And then let's go take a look at the actual updates here. So the biggest difference is our constructor now actually takes dependencies. So we're injecting a to-do store and the to-do actions, and we set those. But now we're also subscribing to this on-emitted event. If you remember the flow, we have an action that calls to the dispatcher. Our dispatcher then sends events out, and our stores can listen to them. But then our stores emit those events. Once they're done updating their state, they need to let everyone know, like, hey, we're good to go. Like, go get all the latest stuff. So that's where we handle this subscription. So now our view model down here, we can do basic switches, or you can handle this with better typing. But in this case, we're grabbing the event type, which is a string, and we have that list of to-do action types like I mentioned before. And these are all just identifiers that are unique everywhere across everything. Yeah, Brandon, thanks. We're already running into issues with our first demo. I'm not even going to try to get hot restart working. So in these events, right, we have our add to do, and when we get that event emitted, right, this is the event that we fired from the beginning from the action from here. But when it comes all the way back around at the end of that loop, we're just going to toast to say, like, hey, we added this item. Hey, we deleted these ones, and you can see for each one of these, we're basically just letting the user know that that command happened. Or if we get an error, we can also handle that in the UI state. So that means that we can handle errors at the global state level and not have to worry about maybe necessarily making them view specific, although we can certainly have both. If you have error messages you need to show that like something happened in the UI and aren't related to data, that's fine. But we can actually take all of the errors just as something that's an observable part of the state from the store. So if some action came through and something went wrong, we can let you know that something happened. And I'll try to demo that in a little bit as well. So let's start from the top and sort of follow along with this flow. And we can step into, let's say, this add to do. So we're dependency injecting our to do actions, and we can now step into this add to do. Now, here's an interesting thing about Xamarin.Forms in particular, is that we essentially kind of have a dispatcher built into the tooling, although I heard rumors of this being deprecated. So if that's the case, the toolkit I put together also has a dispatcher. But we have the messaging center in Xamarin.Forms, which is really cool. So that means that we can just say, hey, messaging center, dispatch this event, right? Because the messaging center is our dispatcher. You get one dispatcher for your entire app. It's perfect. It fits exactly with our Flux model, and we already have the tool. But we're saying, like, hey, we're going to fire this from our I actions, and we're going to send along the type of string. So basically, we're saying that go fire this action type or dispatch this event. We did the add to do, and here's the value. Now, you could always do some other things in here in terms of like the business logic like we talked about. To-dos can do, or sorry, to-dos, reading the wrong word. Actions can actually do things. They're not necessarily just there for emitting events. So for example, here, we could do something like send the new to-do item to an API. And then once it's done, then dispatch the event. Some people like to do it this way, where those sort of external applications or actions are firing and doing all of that here. Some people actually like to do that in the stores and have that all just related to state logic. But in this case, like we can always do more, but because again, this is the most simple app, all we're worrying about is just doing the dispatch at the end. But essentially an action's responsibility is to do whatever it needs to do first, and then tell the stores, here's what you need from this action and here's the data. So this is where the biggest separation is, because we dependency injected this, which means we can already separate that. We can mock this out. We could always just inject I actions separately. But the biggest separation is that from here, this action has no idea what stores are actually listening to the events that it's dispatching. So let's go take a look at our to-do store. So a store basically is just an observable collection of data, but it's not observable in the way that it's like a two-way setup or we're using like a reactive setup and doing chaining of observables. It's very sort of explicit or verbose. So we have this base store, which basically I just set up with a generic type. This is in that toolkit, just, you know, like if you don't want to write this yourself, but we have a base store of type T. We have that on emitted event. That's what our view models were listening to. We have the T type of data. That's the observable part here. You could always have other data structures in here too that are observable. It doesn't have to be one property. In this case, this is a very basic one. And then we also are keeping track of the error. Now we also have the emit event, and we emit it by calling the onemitted.invoke if it's actually registered. And then we also have the ability here to handle the subscriptions to the different types of events. So basically, when we create a store, what we do is to-do store. In the constructor, we're saying, hey, we're going to subscribe to these events from the dispatcher. So subscribe to the add to-do. When the dispatcher says that a to-do is added and it's going to pass in a string, we want to handle that. So that subscription is then going to go all the way through this receive event, and this is also generic. So we have this type data. But this type, this T data, is going to match whatever we put in here. And it could also be empty, like in some of these cases. But let's say, like in the case of the add to do, when we get the type coming through of add to do, we're going to go and update that data. So this is similar to what we were doing previously, just in the view model, but now we're doing it here in the store. So now we do that for each of our other types, and basically we can just cast the data type to what we explicitly need. And then if anything happens in an exception, we're setting the state of the error. But all the way under that, we're always going to call the receive event, which is where our emitting happens that sends it back down to the view model. So it means all of our logic here for updating local state happens. It all runs first because we don't want to tell the view models that something's ready when it's not. And then at the very end, it's emitted. So that means even if something is thrown, we're going to get that error. Now, what I want to do is show you just one more thing, and then we'll run this. Well, I'm just getting my phone set up here. So the only other things we changed is that instead of just registering the view model for dependency injection, we also registered a store in the actions. You could always just register all of your other stores here. That way they can all be injected and stuff like that. But some other points to sort of demonstrate that we talked about, view models can listen to multiple stores. All I'd have to do in this case is just inject another store type here, and we can listen to it. It can also send to multiple different action types. It's up to you how you sort of like scope your stores and your actions. Some people prefer to create a store for every data type, which is what this model fits well, because you just get that data property in the generic, and that's all you have to worry about. And some people prefer to scope their stores to more of a domain. And it fits really well with DDD in that scenario, where your domain of information is within the store. And that way your views can also be aware of what domain they belong to as well. And that's how you sort of bridge that abstraction gap to say, like in this case, if we had the to-do item as one of our domains, then we know that the to-do store is going to have everything we need around that domain, and we can worry about it there. But in this case, it's so simple. We've just got one type that we're worried about, and we're off and running. So let me get Visor running, and hopefully it'll behave with me. And we're going to spin this up and actually debug it. So what I want to do is I'm going to add a breakpoint in our create. Just waiting for it to spin up before I show you my screen. Although, look how cute my dog is. Look at him, he's so handsome. All right, we're halfway through building here. So we're just going to step through it, and you can sort of see the whole flow. The important thing, though, is that I can't just step through all the way to here. So what I'm going to want to do is add a breakpoint to this side as well. So we're just about done. And at least this one, we don't have squigglies, and everything's building and deploying. All right, let's pull up our app here. So we've got an empty list. If I go to create a new one, we get that dialog. Thank you, Alan, for all of your work on this. And I will say that this is hello NDC. That's my to-do item. So I clicked done, which means that we got the results. So just to sort of show you the state of what's going on here, our prompt result is that we got the text hello NDC. So we're going to tell our to-do actions that we're adding one with this text. So if we step into this, we're now going to send over the messaging center that we're going to emit or dispatch this event, the add to do, with this text value. So we have 10, we land here. So now we're within our to-do store. We've received our event, and we're going to take the event type. In this case, that's that add to do identifier, and our data is the string hello NDC. So we're going to end up in this case, and we're going to add to our data, which is currently an empty collection. And then we're going to come down here, and we're going to call receive event, which if we step into, and we're going to call that emit, which then is actually emitting the invoke. So let me go add a breakpoint down here. So in our view model now, the full loop has happened. Our view model called the action dispatched the event to the store has updated its data, And now when we step through, we're going to switch over. It's still the same action type. We don't have an error, so we're going to toast that item was added. Let me pull this back up here. So you can see that item added down here at the very bottom, and we have our item actually added. Oh man, I'm on the free version. Okay. Now, let me show you sort of that error state as well. So, like I said, managing errors in apps is surprisingly difficult, especially at large scale. But if we let our stores handle the scope of those errors, then we can get really, really far with it. So for example, in our to-do store, we have this catch down here. If something goes wrong with our data locally, we're going to catch that and set the state of the error, but we're still going to omit it. So I'm just going to go up here, and we're going to throw an exception. Throw new exception, and we'll set the message to be like, whoops. That means none of this stuff's going to run. The second we get to receiving the event, we're going to throw an exception. What I want to show is this breakpoint. All right, we're back up and running. So this will happen on any event that I trigger. So I'm just going to hit like the populate button here. We're going to throw our exception. So now we still emitted the event. So we're in our view model back here again on our store emitted. The event type was still add to do because that was what happened, but we have an error. So we don't want to say that the item was added. Instead, we fall into this case where we do have an error and we have whoops, which means that I can now do an alert with that error and manage that in state. This is going to run for a whole bunch of them because I did the one that does a ton of actions. Let me get rid of these breakpoints. Oh no, I shouldn't have used the populate one. It's sending like 1,000 of these. Okay, so we've got, I think, 20 error messages that just popped up. And if I just keep slapping OK, you can see the shadows slowly dissolve, which I always think is funny. But that's how we handle our errors. So that's all of the sort of basics of the Flux setup. Now, that's all Xamarin.Forms with the MVVM side. So now, I promised some bonus demo stuff. So let's talk about our bonus demo, which is going to be sort of a Comet/Maui environment with Flux. Now, this is also on GitHub. It's under Comet.Flux. I originally did this way before Maui was even announced, even before it was announced at MVP Summit. And it's using the experimental side of Comet, which is then going to be folded into Maui. And really, Comet is just an entirely new way of thinking about state management and building UIs and building apps, really. And so what I have here is that video, and I can play it again, where we have a similar thing where we can add to-do items and we can toggle them, but this is all running on Comet. Now, let me take you all over there. So Comet was built by Clancy. He's one of the smartest people I've ever met, doing some wonderful things with .NET UIs. And the idea here is that instead of having that MVVM as sort of the forefront of the state pattern, we have MVU, which is model view update. Now that's a single directional chain, and you'll see even here in in Clancy's block diagram, our model is still our model, and it executes our state changes to our views. And instead of using like two-way bindings, we update the view directly, and then it's all this sort of single direction. And you can have sort of scoped state management and abstracted state management. MVU is the design pattern that React.js uses, which is why Flux is like the perfect fit for that. It's exactly why it was created in the first place for abstracted state management. And now it's going to become even more useful as a pattern to use when using this MVU style of .NET development. So just to talk through some of these samples here, I know we've only got basically 10 minutes left, so I want to make sure I cover enough of this. Our view is actually using C# composition to generate it, and then we manage our state. It has hot reload built in, but anyway, to get down to our view, we have state, which we wrap in whatever object type we want. In this case, it's an integer, and we call it the state object. And then if we want more complex stuff, we can create binding objects and mark that as state with this attribute. And then basically what happens is anytime something that is either a basic type of state or an object type of state, whenever that object is updated, we're going to basically recalculate our view and re-render it. So here's a great example here where we have this page. It has a vertical stack layout, so just two things right under each other. We have text, which is a label, and it takes the text of hello world. And then we have a button that's called update, and its text is called update text. And what it has here is basically its click handler. Now this is an actual delegated function, and what we say is grab the state.text, right? So we've got this, and we basically say like to update the text here of this button, instead of being update text, we're going to update it to click count, and we're updating it to click count dot value plus plus, which means that literally in this setup, we're technically updating this state value by sort of throwing this plus plus here. And that's actually going to propagate and recalculate the view so that this update text, or this one rather, is going to be grabbing that new click count, which is really cool. So it's all just like sort of hyperlocal state, that single loop of things. Now, the other cool thing about Comet and eventually the tooling in Maui is that we don't have to use Visual Studio and all of the sort of UI components of building things. Instead, we can use, where'd it go? Comet.flux. We can use VS Code. So I'm literally going to just say open in code here. When we expand this Xamarin.flux.comet example, we have the same setup where we've got actions and stores, right? Our to-do store is exactly the same as it was in our other example. Let me actually, that's fine. So we have the same subscription events. We have our data that's initialized to an empty list. It's the same receive event. It runs through the same logic. All of that is just as usable as it is with the MVVM setup, as it is with the Comet setup, because the Flux side of things is an abstraction on top of it. And especially when it comes to the stores, this store doesn't care what view hit it or what was executing it. It just cares about managing its state. Our views, though, are simplified. There's no view model folder anymore. Instead, we just have our main page. So our main page is then either dependency injected or set up with a new store and actions. So that view model part of it is gone. We are now in more of that sort of like pure Flux setup, where we have our state as the local list of to-dos. We have our actions in our store. We're generating a new list for the state, which is based off of the to-do store's data. So we're saying that this new list, which you'll notice is a list and not an observable collection of to-dos, and we're grabbing the to-do store's data, which is also a list of to-dos, and we're also doing that subscription to the on-emitted. Basically, same thing we saw in the other one, where we don't have to necessarily worry about all of the state management locally. Instead, we just receive the event from the store. In this case, we're console writing instead of using Alan Ritchie stuff because it's not built for Comet. And we're just saying reset state, which is basically saying like, hey, when we get this add to do, just like go recalculate stuff. Now we could also, just done this down here at the very end, and we can just get rid of all of these, basically to say like, hey, when we receive an event of any kind, go update the state and basically recalculate everything. So we console write line at this is added, and then our state is recalculated here when we call reset state. And we're saying that the list of to-dos is also just going to be that the list of data from our store. So this is like much more explicit with the way that Flux is also built in React. And then down here with our view render, we have a button called add and the button for toggle all like we saw. And then we have this list, and we're just passing in that value of our state. So this is a list, and we pass it in within a frame. And so now whenever we update it, right, whenever we call reset state, whenever this property is changed at all, like we do here when we're setting it to get to the new to-do store's data, all of this gets recalculated, which means we recalculate the to-do list view and we pass in the new list. And then this to-do list view is literally just like it's a stack of things. It's not even like an actual like pure list view, but we register it. It inherits from list view of the certain type. We take in that list of to-dos that we passed in from our actual pages component. But now this view can also contain its own state if we wanted to. And it's really nice for building that sort of componentized structure. So, I'm personally really, really excited for this future of .NET client app development, supporting still the MVVM stuff, but this MVU way of developing is so nice. It's so much easier for building componentized and composed UIs, the way that people that use React do, and for managing your state in more abstracted ways and getting access to easier implementations of other design patterns. I'm personally really excited for this. That's why I really wanted to dive into the Comet side. It's funny, I first learned about this right before I gave this talk last year when this was still like super experimental. And I was like, oh my gosh, this is way too perfect for my Flux talk to not talk about, way before Maui was ever announced and anything else like that. And it just fits so perfectly within this design pattern, because it's really the structure that it was meant to be. We now have the unidirectional data flow from Flux for our data structure, and we have the unidirectional data flow of local state within any component that we want. And it's just like the perfect combo of being able to track things, compose your views, and just make everything work. So that's all I wanted to show you all today. Thank you for joining. I'm always streaming on Twitch now, Sundays and Wednesdays. So if you want to hop in and talk about tech or sort of watching the cool projects we're building, definitely join me. It's twitch.tv/swab_pirate, just like the Twitter handle. We just built a Alexa-powered controller using Arduino and .NET to be able to control our character in Call of Duty by just yelling at our Alexa device. We're always doing some pretty cool stuff. But thank you all for coming. Thank you for joining, and thanks for everyone that participated in chat. And I hope you enjoy the rest of NDC Oslo. And I'll be around in Slack all day too. So, feel free to DM me with any other questions or thoughts or anything like that. I'll be in the hallway track as well. Yeah, thank you, everyone.